again and share screen. You guys can hear me, right?
Yeah, you're good.
Nice. Okay. So that kind of wraps up. It broke off at like what was he talking about? Anyways, to summarize, packages or like the data sheets will tell you the layout of the component, how it looks like in 3D, and it'll give you like a top view, front view, and a side view, as well as like the lead spacing. And then from that, you can make your footprint. And if it does give you a recommended footprint pattern, just use that. It's easier and it will work. And then it gives you dimensioning tables if you don't have the latter option, or if you want to make your own footprint for some reason. So A365 has helped us a bit with this because a lot of components are found on the server that have their footprints already, and they are good to use. So we just use them if possible. But if we have to make our own footprints like back in the old days, this is what we really care about in the datasheet. And then that ends off the data sheets. You'll notice they always end off in packaging. It's like the last thing. And the packaging differs based on the packages they offer. We care about anything with leads. Once again, we want to stay away from using ball grid arrays, especially. Ball grid arrays also are only like really usable for PCBs that have more than like 2 to 4 layers, because you can't trace the middle section unless you come at it from another layer. So you generally need a layer per like outline of square. For example, this has like 1, 2, 3, 4. You need at least 4 layers, most likely at least like 8 or 6 or 8 to be able to actually route this. So that's just in general. You're not going to find this on our team. We'll never use a bulk grid array, but it exists. And if you go into industry, for example, Apple uses like a shit ton. So yeah, anyways, okay. That kind of like is a good breakdown of a datasheet, and I'll put in the Google form how that kind of went. And please like ask questions or ask me to clarify any parts of this, especially if you're going to review this video later, or if you're going to look at these slides again. Again, we'll be sharing that. And then I want to wrap. I was going to like back to the agenda. I wanted to show some DigiKey searching and the best way to find parts on DigiKey, which is really important. And if time permits, talk a bit more about how to use Altium 365, because I get a lot of similar questions. So I thought that it would be a good time to clarify, but we're almost at an hour anyway, so that's not going to happen. Hopefully I can set a time later to talk about Altium 365 and general things. So we will now have our sourcing on DigiKey part of the presentation. Also, I noticed that a chat like bubble. Is everything good? We're good? Okay.
Yeah, that was Nita.
Okay, cool.
Oh, wait. James Joe asked what MCUs are used for firmware.
So we only use one MCU in our entire car. All of our controller boards, you know, those one boards that tie together our entire CAN network, they use the STM32F072 model. It's the data sheet I was just going through right now. Firmware only has to care about this MCU. That's all they care about. They care about other components that are slaves to this MCU, which are like all the components we use for digital logic, like SPI components, SPI isolators, like the Numeras for fluorescence, things like that. But the master in most of these relationships, or all of them, is this STM32F072, which our old lead Taiping spec'd out. And we have been using because it gives us enough GPIOs. It has the CAN interface that we care about, and it has the SPI I2C UART interfaces that make it very versatile for all of our applications. Does that kind of make sense?
It's also just a pretty popular microcontroller, like commercially.
Yeah, there's like STM is like has this thing, or STM32s have there's this application called STM Cube or something like that, where you can like figure out what microcontroller fits your needs. And there's a huge lineup of STM32s. So I'm thinking like Taiping probably just used STM Cube when he found this, or at least verified with it. But if you're curious and you ever want a microcontroller for any of your personal projects, I suggest using that ST has a great lineup, especially in the STM32s. So yeah, just side note. Cool. Okay, yeah, let us talk about how to find things on DigiKey. So I find, and this is from like lots of like trial and error, that the easiest way to find things on DigiKey is to have the most general description as your search inquiry, unless you have a specific component in mind, which you probably don't in many cases, and then filter from there. So what DigiKey does is it has, like the main product page, you have your search entry, and then yeah, you can search whatever you like, and it has like tons and tons of products. It also has other I guess things you can check out, like new products, reference designs, its blog, calculators, things like that. But we don't care about that for now. We care about sourcing components. So this is a really general procedure I find works pretty well. Have a general search inquiry, use filters. And then if you're finding a replacement part for something else, you can instead find by a similar description. So for example, if I wanted to find a similar part to this MOSFET, I would use this description. I want a MOSFET N channel 250 volts, 64 amps specifically. For some reason, I want that. I'll copy it, and then I'll like search it in DigiKey, and I'll get results that fit this description, and that'll most likely be very useful for me. It'll be really quick to do. I usually don't like to search by, if you're doing that, don't include the packaging, because it will really limit your search results, and we don't care about the packaging unless it's QFN, which means it doesn't have leads coming out. So, and there's a lot of, you'll find that there's a lot of packaging names you're probably not familiar with, but just know if it has like a N in it, it's usually like it has the pads underneath the main body, which is hard for rework. And if it has like an O or a T, and you can always search up these packages like online, or like an S, it usually has leads coming out. Kind of my way to indicate. I also just look at the models, or I like copy this into Google and look at what the package says. So S is for like surface mounts, you'll find that, or like through holes have different packaging. That's not important right now. Okay. So yeah, you can filter like that. Don't include the package, and then you can filter from there. And then always choose these options, which are in stock. And if active is available, try to choose active. If you somehow choose active and get like 0 search results, and you really need a component with the specific filters you already have applied, just don't worry about active. We can deal with the fact that it has been obsolete. What in stock means is that we are able to purchase the component and get it immediately. It is in their facilities, but active means that it's still in production. Components will go out of production and they'll become obsolete. DigiKey might still have them in stock, but if they ever run out of stock, we're kind of screwed. They won't be producing it anymore or getting it anymore. So yeah, unless you can find it in other means, like from other vendors or suppliers, I mean, like Mouser or Arrow, yeah, then we would look at that, especially if it's a component we really need. But preferably when you're specing things, just spec in stock and try to spec active. So our demo will begin with sourcing passive components. So I'm going to look for a high voltage capacitor, specifically this capacitor, or like a capacitor that's 22 microfarads that I needed for SolarSense. And we'll get started. Okay, so literally what I do for like passive components is I search capacitor. And that's really like vague. Oh, I spelled that really wrong. Capacitor. Oh my God. Okay. And then I look for the kind of capacitor. I know that I'm looking for high voltage capacitor, and just from like general knowledge, I'll be looking for an aluminum electrolytic capacitor, because ceramic capacitors have huge DC bias at high voltages. And I care about getting a 22 microfarad capacitor. So I'm going to click that. So yeah, when you're searching for things like caps or diodes, like you can search, generally don't search diodes, search like what kind of diode, like Schottky, Zener, TVS, things like that. But it'll ask you to filter a bit more before you can actually put in the filters we care about for electrical characteristics, because DigiKey has like arranged their components to their functional groups. So first thing I click is in stock, better be in stock. Capacitance, I want 22 microfarads. A lot of options here. Voltage rating, I want min 200 volts because this is going on our, what's it called, our high voltage line. And so rating it 200 is just our like standard because our high voltage line has max 154. Having a bit more than your max is always useful because of tolerance reasons, as well as like just in general, if there's like any spikes, which there won't really be because batteries are like the nicest DC supplies. But yeah, it's always good to spec a bit above. So especially when you're looking for ratings for voltage. And then
is that the minimum or the maximum voltage?
That's the minimum. My minimum is 200. If I don't put a max, it'll be like, oh, everything over 200 is great. Okay. So 200 for high voltage components is the minimum. Yeah. Always try to select that.
Yeah, I just thought that was like a selection option where you select max or min.
Oh, okay. You can select either or. Like you can select just the min, and then it'll give you everything max. And like usually you won't find a component that works best for you in terms of pricing and stuff that's really overrated. So like keeping that like that will just give me the most results that I could filter through more. So yeah, you don't need to put a max, which is useful for this case. And then for capacitors, I care about ESR, which is the equivalent series resistance. I want the minimum series resistance, but like that's just like a minimum. I'm not going to like if I chose to like, oh, I want 1.5 because it's the least, I'm gonna get like no results because that's a very specific filter. And like this whole category, I'd have to be like, oh, do I want like less than 5 milliohms? Then I'd have to go clicking like a crazy person. So I'm not doing that. I'm going to filter by other things and arrange later. I care about if it's AEC Q200. I'm just going to care about that now. Or actually, if I do automotive, do I get more results? So basically, AEC Q200 is a rating for automotive qualification. We are a car, we care about automotive qualification, but many times components are still okay to be in our car because their like temperature ratings meet the car temperature rating. So we don't care at that point. And then I could look at size and dimension if I really cared. Once again, we don't care about size and dimensions most of the times in our car because it's huge. Electrical systems, like realistically, don't take up way too much space. And we aren't limited by what's it called? Space. Yeah, that's what I'm trying to say. Okay. So you know what? I don't have way too many components. Maybe I can like put a tolerance like plus minus 20 to be fine. I mean, just to search like to take out some. Well, actually, like if there were less packaging options and it was just like cut tape, DigiReel, and tape and reel, I would just select cut tape because that's the only thing we can purchase in. But there's a lot of options, and we're good with everything except for DigiReel. And tape and reel, really. So I don't care. And then like usually for manufacturer, I don't filter that out unless I have a certain component in mind. I'll look through when I'm comparing them to make sure the manufacturer like is like I'll try to source things that are well known. It's not the like first priority in terms of filtering, but it's just useful. So you can apply filters and then still filter, which is really useful. Because it like narrows down your search results and then you pick based on what is really useful for you. So let's just say I really want a through hole capacitor, or actually no, I really want a surface mount. I don't want a through hole. Then I can apply that, and then I get all these results, and I've like narrowed it down to like 17, which is like basically nothing. So I can then look at the manufacturer just like on the side, like Panasonic Electrical is pretty good. Like we use a lot of their components. And then I can do things like filter by price. So if you press the up arrow key on the price, you get the cheapest to the most expensive. I then look at like, oh, Panasonic, that's good. There's a lot in stock, that's good. I have all the options of packaging I care about. I can use cut tape, that's good. I have the capacitance 22 microfarads, I wanted that. Voltage ratings 250, that's also good. It's polar because it's an electrolytic capacitor, they're going to be polar. And then I look at, where is it? Ratings, 560. Well, for some reason, this doesn't really tell me the equivalent series resistance, which is weird. What happened? Oh, I guess they must have like similar ones. But then I can click on the like actual component, and then here is where the knowledge of how to look at data sheets is very useful, because then we go to the data sheet. That's like the last, like you look at a component and then you really look at the data sheet to make sure that it fits your requirements. So yeah, this is definitely a possible component I could use. I'm not going to look at this really detailed right now, but like I would want to check the ESR as well, because I want lower ESR. So okay, that's a good summary of passive or a passive component, and kind of like just the filtration technique I find useful. And then we can look at how to source ICs. So that's a bit different because there's a lot of different parameters based on the IC you're looking for. For example, my example here is for a LDO, or a linear dropout regulator. So I literally, to begin this, I just searched up LDO. That's the acronym. And then I see, like, usually you'll know that you have a really good vague general entry when you see like a lot of items, like thousands of items under the category, because you want the most results and then you want to trim it down. You never want to like limit yourself to like a couple of results because you entered too many inquiries into the search bar. So I'm looking for this voltage regulator, right? So I I'd search LDO, and then I look at what's important. So got to be in stock first and foremost. Output configuration, I mean, preferably just positive output. Voltage input max. This is like, okay, voltage output. I want an LDO that's fixed, or it can be adjusted and fixed. And that just means that I have a specific output in mind, which is pretty common, and it should just like let me output. I want to output, let's just say 5 volts. So I'll select the 5 volts. There's a lot of different kinds of 5 volts. I mean, I'll probably get the most results just searching 5 volts, because that just means it has one regulator, which is what I want. And then it's just output is just 5 volts. That's all I care about. And this is the fixed category. So I care about that. And then this is an example, so I don't really have things in mind, but I could care about the mounting type, packaging. More importantly for regulators is QASync current. Usually for this, like you want the lowest QASync current. QASync current is like the I guess like when it's not operational or it's not being used, the current that's leaked, and that is just power loss, right? You want the least amount of power loss, so you want that to be low. And then I could also filter by what current supply I'm expecting. Maybe this is being connected to its own 12-volt cell that has, or 12-volt battery pack that has like a certain current output max, and I could put that in. But this is an example. I don't know. And then yeah, current output, also what I needed to drive something at, if I have that, don't have that. And then voltage input, that's also important. So this is the max, right? And the unfortunate thing is, I'm pretty sure before there used to be like a, what's it called? A min and a max for this as well. But I don't have that right now. It's unfortunate because when you filter things, like, look, I put 11, and that's not really what I wanted, but I put 11 and I got 0 results. That's because filtering by this is very specific. Like each data sheet or each component will say its own input max. But if my max is like 15, like my actual max is like really like 14 or 13.5, because I'm just like basing this off of like our 12 volt reference, and a bit of tolerance for like any, I guess, spikes, but there shouldn't be. It should be really closer to 12, so like 14 is a good max, I guess. But if I search 14 and 14.14 and 14.5, I get more results every increase I do, because I'm like expanding my range. And usually, like, that's why I didn't want to do this filter, because it's kind of annoying, but there should be a min and max on this. I'm pretty sure there were, but there isn't for this specific search inquiry. So I can search until like a reasonable amount, let's just say 18. And then I get like a lot more results. I can apply that and filter those. Right, so I still have like a ton of results. I'd say you are in a good state of like just looking through all the components when you have like less than 100, unless it's a really common component like some resistors 0603, you'll find like hundreds and hundreds of the same thing with almost no difference. So it depends on the components. This is LDO, it's kind of similar. Like there's a ton of linear regulators I could look at. So I might just give up and look at filtering the table. So voltage input, voltage output, dropouts. I can look at these. I can look operating temperature. I can look at all these things. And if I really wanted, preferably when I have less results, I would filter by price, because I'm going to get, oh, that's pretty cheap actually. And it's from Diodes Incorporated, or even I could look at this microchip one. So there's oftentimes many ICs that will work for you. So if I purchase by price, I'm just making a economic effort to find a low costing solution. And since I kind of like put all the filters I really care about, I can just look at the cost at that point, right? Because yeah, we want to save money. And then we just care about the manufacturer and the packaging. This is an SOT25, that's fine for me. It'll package well. And I can also kind of see that from the model. Like there are leads coming out. It looks good. So that's kind of how I look for ICs. Hopefully that's helpful. And then the final thing, just as a fourth and final example before we end this, I know we're kind of over time, is transistor sourcing. So I find the easiest way to do this, and by transistor I mean a BJT or a MOSFET, is literally just search either word, MOSFET. And then I'll get, again, that kind of like pre-filtration page DigiKey gives me, where I choose what kind of FET do I care about. And you'll notice that this one is single, this one's arrays. I don't want a MOSFET array. I get way less options and they're way more defined. I just want a single MOSFET. And specifically, I was speccing for, like this example, I was speccing for this guy, this N-channel MOSFET that has to have a VDS of, that means has to have a difference in drain to source of 200 volts because it's on a high voltage line. So I can just search from there. N-channel, that's the kind of MOSFET I want. I want it in stock. I want min 200. I might know the current continuous drain I want. Like, again, this one is kind of annoying because I wish it was just a min I could choose from. I'm not sure why DigiKey doesn't let me do that anymore. It did before. Whatever. I won't search by that. Or I'll...
You can hold shift and select the whole range.
Oh yeah, I can. I forgot about that. Okay. But, that's still annoying. It should just let me. I'm pretty sure it's because it has like multiple options that don't really fit into a range. And I care about, let's just say like 30, I don't really know for this component, to a reasonable amount over, let's just say 80. Then I get 700 results. And because I'm looking for transistor or MOSFET and N-channel specifically, I care about the VGS thresh or VGS on, or the max VGS basically to turn it on, as well as RDS on. Also, I would really care about. because I want the min amount of resistance, so I'm not getting too much drop from when the MOSFET's on. And this again, like most of these characteristics I care about based on the FET implementation, the actual FET I'm using. So if you're not really familiar with like RDS and what that means, yeah, that's just like looking at how the FET works. So back to like what this is really about. It's about looking at how I can use all these filters to my advantage. So I can choose operating conditions, FET features. If I really like wanted a specific FET, like another one on my schematic is this guy, which is depletion mode transistor. And we're like this, the one I'm really specing for isn't that, but if I wanted a depletion mode, it would be a certain feature and I'd have to choose that. But that doesn't work in this case, mostly because it was a pretty high voltage VDS I chose. But anyways, so I can keep searching and I can like usually just like adding a filter and then pressing apply all is better, because then you can like backtrack the stages and like change your filters and then go forward in stages and change your filters. By the way, I'm just like going back and forth with this, and then edit to get more results or filter out more results. So yeah, it's usually good to just like put in 1 or 2 and then apply and then keep putting and then applying to filter out your choices. Cool. And then like at the end of the day, you're probably like, for a lot of applications, you might end up with like hundreds of options, in which case, yeah, you want to do the price thing, you want to do the manufacturer thing, and you want to make sure you look through the data sheet. And that's the very most important part. Because once you have chosen something or you're kind of like leaning towards something, if you check the data sheet and you realize something is out of spec, you know that you can then filter you can go back to this page and filter for that spec. So yeah, that's like the timely way of doing this. And yeah, using the filtration technique is the best way to find components I find on DigiKey. So does that kind of make sense? And yeah, that was kind of the end of this presentation. I know there's a lot in this. It's just that the original intention of this this slide or this knowledge share I didn't find very useful or content heavy for the rest of the 1 hour. So yeah, I wanted to add things that are really these, like being able to break down a data sheet, be able to search and spec components properly is very important. So cool. That is it. I have acronym abbreviation page. I'm probably going to add more, so it's a bit more useful for all the terms I've been throwing out today. But yeah, cool. That's our end. I'm sorry that took so long. I guess we're only 20 minutes over time. We are always over time.
Just another note on the DigiKey searching. If there are any filters that you don't know what they mean, like ripple current for the capacitors, just Google it. I think that's the easiest way to figure it out, and you'll probably find an application note or something explaining it really well.
Like in lots of cases, you don't care about every single like spec of a component. Like for example, like in the data sheet, you'll see like a lot of operating conditions, and it's good to know what they all mean. But when you're like searching for something, you only really need to filter by things that are specific to your design. And then you can look through the data sheet and see the parameters that affect operation. Yeah. But yeah, anything package related, just like search online. There's lots of codes for packages. So I don't remember what everything looks like. But DigiKey also gives you models, which are pretty useful. Also, another good thing about DigiKey is they sometimes give you in media and downloads, like the actual component. If you can't find it on A365, sometimes you'll find it here instead. If you can't find it there, then you'll have to make your own footprint and schematic diagram. But sometimes you'll find it here, which is pretty cool and useful. Cool. I think that's a good place to stop. Does anyone have any questions, comments, maybe from other leads? Like Micah chimed in. If anyone else has any strategies, it would be awesome. Let me stop share. It's here. Okay. Ah, that was a lot of talking. If not, I'm going to be sending, again, because we are done our general overview of the electrical systems explanation, I'm going to be sending out a form to see how you guys feel about understanding how the car really works at a high level. And then we can get started, like, well, we kind of did just start on like more detailed knowledge shares from our deep dives. But yeah, then we can really start on like looking at different boards, which is what the intention is for the next couple of weeks. Cool. Well, thank you, everyone. And please always let me know if you have questions. So thanks.